So anyway, this is a homemade telescope. So I started making this back in college. Basically in college days I ground the mirror. And then for years and years, you saw that story I had several weeks ago at the end of the video, the story behind me finishing this up. My son was anxious to see a once-in-a-lifetime astronomical event called the transit of Venus, where Venus goes across the face of the sun. He said, "Dad, you have to finish your telescope." So I did, sort of, and that's what you see right there. But since then, I've continued to modify it. It's a project that's never done. So this type of telescope is called a Newtonian reflector because it was invented by Isaac Newton. So basically, the way a telescope works is you have a primary optic which collects a lot of light. The more light you collect, the better. Hence, you want bigger mirrors, bigger lenses. And then you focus it down to an image. You've probably done that with a magnifying glass, where you try to get an image on the wall using, something across the room using a magnifying glass. Well, that's what this does. It focuses the light down to an image, and then you use an eyepiece, which is like a microscope, and you look at the image. And what this does, the light comes down here, and it starts to focus up here, and then it reflects off of a little turning mirror on the inside, and so that shoots it out the side, so you can now look at it with an eyepiece. So that's the basic principle behind it, and I don't know how many of you can see if I can point it at you. You can see the mirror down there. Fortunately, the laser pointer isn't on. But so this is called an equatorial mount type stand, and what you do is you point this axis at the North Pole. And so I have means for adjusting it to make sure you point it not at the North Pole, you point it at the North Star, which is what the Earth's axis points toward. So you point it toward the North Star, and then once you find your object using your finders, then and you got it on target, then you engage the clock drive, which is with this clutch. And the clock drive is battery powered. That's this gizmo, and what it does is it counteracts Earth rotation so that this tracks the object that you're looking at. And you have to do that because, especially with high magnification, those little objects you're looking at move across the field of view pretty quickly. And so that's a clock drive. My kids and I made that. It actually works. We got to try it out this summer. We saw Venus, the crescent of Venus. So that's my telescope. So I wanted to talk about astronomy and cosmology and how it points to the glory of God today. And so that's kind of the topic. So how many of you have been on a camping trip in tents and you had to go to the bathroom in the middle of the night? And you crawl out of the tent, you have your flashlight, because this is a campground that doesn't have all these security lights all around. You're actually out, out in the wilds, okay? And you go out and you stand up and you go, oh! And people have been doing that from time immemorial. They've gone out and they've looked out at those heavens, and it's just awe-inspiring. It's, the Bible says that the heavens declare the glory of God. It's this non-verbal language, but it's a language nevertheless. It's proclaiming His glory. It's proclaiming His power and His deity, and so forth. And so that's one of the things the Scripture, the heavens do when we go out. I mean, some people go out and they hear music, the music of the spheres as they see this clockwork type action of the heavens as they turn around the earth, and in our perspective, so forth. And it's just beautiful. And of course, I love Psalm 8. He says, "When I consider your heavens, the work of your fingers," I think of just his fingers. It's the work of His fingers, right? He didn't have to struggle with it. It's just little fingertips, right? Just spread them out, When I consider the heavens, the work of your fingers, the moon and the stars which you have set in place, what is mankind that you are mindful of him, and human beings that you take care of them? So it really speaks to, the psalmist is wondering how insignificant we are compared to God and to His glory. And that's one of the things that astronomy does for us, is we realize how awesome, how small we are in comparison to the glory and power of God. So anyway, of course it says in Genesis chapter 1, God said, "Let there be lights in the vault of the sky that's to separate day from night. Let them serve as signs to mark sacred times and days and years, and that there be lights in the vault of the sky to give light on the earth. And it was so. So it talks about God is the one who created the heavens. God is the one who populated the heavens with the starry host. And one of the things they do for us is they mark out times. It's, in a sense, it's a big calendar for us and a clock for us. So as the ancients looked up into the night sky, they saw all these points of light and they started connecting the dots. And lo and behold, they came up with pictures. So here's what we call the Big Dipper. It's actually, most people call it the Ursa Major, which means the Big Bear. So he has a head and paws too, and you see that little red line. Astronomers actually define the areas of the sky into constellations. So this dotted line shows the area of the sky that is referred to by Ursa Major. So if they give a star name or a number or a location, they'll oftentimes tell you what constellation it's in, and it's just within that dotted line. So the ancients would, of course, constellations are referred to in the Bible. In the book of Job, it talks about the Pleiades, which is this small cluster of stars that I like to say looks like a question mark. It's called the Seven Sisters. And then you have the constellation of Orion with its belt and its sword. And then you have the Big and Little Bear, or the Big and Little Dipper. So Job talked about how it was God who set the laws of the heavens in place. So the ancients would look up with this, and through this they could see what time of year it was, which is important for planting crops and harvesting them. So summer constellations, you see, if you go out at night, a normal time of the night, you'll see the Big Dipper nearby. But if you go out the same time in the winter, it's a different constellation, the constellation of Cassiopeia. So the constellations have different visibility during different times of the year. Very important in ancient society is to know those times and seasons and so forth. So then we have the wandering planets, or the wandering stars, which are called planets. So most of the stars, they're all oriented together and they rotate together, but you have some stars that kind of wander against the background, and those are called wandering stars or planets. That's what the planets are. So here's a time exposure of the planet Mars moving across the stellar background. So it begins on August of one year and ends April of the next year, and you can see how it does this little loop-de-loop. So it's moving along against the star-spangled background, and then it just kind of loops around, and then it continues on again, and that's called an epicycle, that little loop-de-loop it does. And so the ancients were fascinated by that. It's interesting, the planets are mentioned in the Old Testament, but obliquely, actually in the Bible. So here's one. It's in Jude. It's comparing false teachers to the wandering stars, for whom the blackest darkness has been reserved forever. And then it talks about Jesus in the book of Revelation, Jesus being the bright and morning star, that bright planet that kind of heralds the coming day. You see that bright thing in the morning, bright star before the sun is up, and that's heralding that sun is nearby and the sun's going to be rising. And so book of Revelation, John refers to Jesus as the bright and morning star. So it kind of references the planets obliquely, and the good reason is because the ancients had the practice of astrology, which was trying to foretell the future using the stars and the moon and the sun as they moved across the starry background. And that practice was forbidden in the Old Testament because God said, you're supposed to get your guidance from me, not from the astrologers. And so here's what astrology is about. So the planets and the sun and the moon all move, they're all rotating around in a similar plane called the ecliptic plane. And that ends up forming a band in the night sky. So the sun and the moon and the stars all move across this band of constellations. So those constellations are called the zodiac constellations, and they have a different constellation for each month. And of course, probably most of you know what your sign is, right? When you were born, I was Gemini, month of June, so all this kind of stuff. Well, we were forbidden to actually look to that for guidance, but that's kind of what the astrology is all about. So anyway, but the Bible does talk about signs from heaven heralding the end times and the return of Christ. It talks about men's hearts failing them for the signs in the heavens. So the sun being darkened and the moon being turned to blood and the stars falling from the sky. I just can imagine horrendous meteor showers and stuff like that, you know. So people were going to be horrified at these signs that they saw in the heavens. So I want to talk about astronomy before Copernicus. Of course, you probably figured, and it was true, that the ancients thought of the earth as being flat and the sky being a dome with holes in it and lights on one side or the other, and water above and air below and water underneath the earth. So that was some of the ancient cosmologies. Some of that, and we'll talk about that, gets into the poetry of the Old Testament. So they use some of these images from these ancient cosmologies in the poetry of the Old Testament because they were talking the language that people understood. But turns out the Greeks were the one that advanced things. So Aristotle came with the idea, well, let's think of the heavens as being a series of spheres, maybe one for the starry heavens, other spheres for the planets, and these are all rotating around the earth. The earth is in the middle. And guess what? We think the earth is actually spherical, not flat. So the Greeks concluded that it was spherical, and they could tell this because of their travels. They go further south, and the North Star would go down lower toward the horizon. And they go north again, and the North Star rises, you know. And so that's an indication of the Earth as being spherical. And then they actually made an attempt to estimate the diameter of the Earth, which I think was kind of wild. So this was during the time of the exile and post-exile, with the Jews returning to the Promised Land. All that was going on back then. Then you had the Ptolemaic model of the universe. I think there's a little more detail. He was trying to explain why these planets do the loop-de-loops. So he was coming up with spheres within spheres, and, you know, kind of like this gear-like machinery for these planetary movements to all be synchronized and so forth. And then you have the medieval universe, which is somewhat similar. So we need to. So you're often told, well, it used to be that the ancients thought that the Earth was in the center of the universe, and therefore man was the one about whom everything revolved, and this man was dethroned when Copernicus came along and said, well, the Earth isn't in the center of the universe. Well, that's actually not true. So they thought of the center of the universe as being the sump of the universe. So that was the low part. So as you went up, you got more into the heavenly realms, into the realm of perfection and so forth, and above it all was God and all his glory. So they kind of viewed the center as being where God was in heaven, and earth is kind of being in the hinterlands, way outside, in the outskirts, the ghetto, so to speak. And so that's the way they viewed it. And they also were acutely aware of the insignificance of the earth and of humans on it relative to the universe. And so I have a book over there. It's called The Discarded Image. It's actually written by C.S. Lewis from a scholarly point of view. And he talks about some of these things, a medieval model for the universe and how it manifested itself in literature and so forth. So feel free to page through it over there. So anyway, so that was astronomy before Copernicus, and then Copernicus came up and messed everything up from an intellectual standpoint. He said, you know what? Things would be a lot simpler if we just said that the sun was in the center of the universe rather than the earth. If you do that, then you don't have to have all these gears and wheels and stuff to explain the motion of these planets. Everything, is going around the sun, and that's good. And so this was actually kind of earth-shattering, I think, from an intellectual standpoint. It basically ended the medieval model of the universe in which all their literature was based. But it really had very little effect on the church. It wasn't a big theological upset. Now, certainly people had arguments, but, when all the dust settled about, is this really true or not? It's like, well, yeah, okay. Earth has been promoted. We're no longer in the sump. We're now up with the other heavenly bodies like Mars and Venus and these other places. And so it really wasn't a big issue in the church of that time. And then came the telescope. You realize you didn't have any magnification to look at things. You just used your naked eye. Now you had more and more accurate ways of measuring the position of the stars, so they would make observatories that were these big round affairs, and then they could kind of mark on the wall where the star was at a particular time and date and so forth. And so from that they could kind of deduce the motions of the planets and seasons and all that kind of stuff, but they didn't have any magnification. So along came some guy who invented the telescope, and Galileo took it and pointed it at the heavens. And so he noticed that there were moons on the crater. If you look at the moon with your naked eye, you really can't see craters, right? But he used his telescope. Oh, there's craters on the moon. He pointed at the planet Jupiter. Oh, there's moons going around it. He looked at the Milky Way. They didn't know what the Milky Way was. He could see that it was made up of zillions and zillions of stars. And then he looked at Venus and saw that it was a crescent. And guess what? That was proof that Venus goes around the sun, not the Earth. And then Kepler came along and he explained the planetary motion in a way that allowed you to predict where a planet was going to be at a particular time and kind of explain it in terms of mathematics. And so that was pretty neat. And then along came Newton, who came up with this theory of universal gravitation. Now you have the keys for understanding the motions of the heavens and the Earth, so to speak. And so Kepler's laws can be derived from Newton's laws of gravitation and so forth. So that was pretty revolutionary from an intellectual standpoint, is to be able to come up with this universal law of gravitation, which we talked about last week, by the way. So I just want you to know the last week is the hardest it's going to get. So for those of you who missed it, we talked about algebra and calculus, trigonometry, imaginary numbers, complex arithmetic, and we had a wonderful time. All right. So that was the birth of modern astronomy. So for the next 2 centuries, no earth-shaking discoveries, but just bigger and bigger telescopes, new methods, and so they were discovering these clouds. They called them galaxies or nebula and stuff like that. So they would catalog those. They didn't know what they were or where they were, but they found them. They discovered a couple of new planets. And then there were some scientific discoveries that would help in astronomy in the future. And that was, number one, was the Doppler effect. Of course, that came along with the train, the invention of the train, right? The train was going away from you fast enough, you could notice the drop in the sound of the whistle as it went away from you, or the increase in the pitch as it came toward you. So that's called the Doppler effect. Well, that extends to light too, right? Light, so high pitch corresponds going more toward the ultraviolet, blue end of the spectrum, X-rays and so forth, and lower pitch is like going toward the infrared and radio and so forth. So you now, by looking at the Doppler effect with radiation, with light, you can now discern the motions of the heavenly bodies toward you and away from you using the Doppler effect. And then there was the development of spectroscopy, which I practiced to say correctly, finally, okay, and that's basically, you can break the light from anything, and it'll break it up into these constituent colors, and that's called the spectrum of the light coming from it. And it turns out that each element has its own characteristic fingerprint or barcode. So there's a barcode for when light is absorbed by the atom, and there's a spectrum associated with light being emitted from the atom. And so by doing that, they can now discern the constituents of stars, because they break apart the light and they can say, oh, this is the hydrogen, fingerprint. Oh, here's oxygen. Oh, here's nitrogen. And so they can break apart the light to determine the constituent elements. And then by looking how the barcode is shifted, they can tell what its relative speed is. So that's what they call the redshift. So it's either slow, if it's moving away from you, it shifts more toward the barcode shifts more to the red side. It's toward you, it's more toward the violet side. So anyway, so it turns out to be very important for the next century. So now we have the discovery of cosmic expansion. I would call this the most important, I'll be bold, I'll say it's the most important discovery in the history of science. That's my bold claim. And because it points in a way that is almost inescapable to a creator. All right. So the story behind it is you had Einstein developed his theory of general relativity, and then a guy by the name of George Lemaitre was looking at the theory, and he says, you know what, this theory really says that the universe should be expanding. And then this guy by the name of Hubble went and took redshifts of all these galaxies, discovered, number one, they're actually outside our galaxy, and number two, the farther away they are, the faster they're moving. And so this is consistent with this cosmic expansion. And what it means is as you roll the film forward, things are getting further and further apart. As you roll it backwards, things get closer and closer together to a point. Yeah?
I watched probably every episode of the Big Bang Theory, and I really talk about dark matter a lot. I can't understand what they talk about when they suppose the dark matter. That's just the dark empty void of space they're talking about, or what?
No, what it is they look out. So we got Newton's law of gravitation, and you have Einstein's, expansion on it. and they infer the presence of matter that they can't see. So they're looking at the stars in the galaxy, and they're mapping out the velocity as you get further and further away from the center of the galaxy, and they can't explain that velocity profile unless they infer a halo of matter around the galaxy. And they figure it can't be ordinary matter. Of course, they have all sorts of theories as to what it can't be ordinary matter because it doesn't emit light and it doesn't absorb light. You can't see it. It's something that we can't see. And so that's what dark matter is. And by the way, it's not 100% certain that it exists, okay? It's inferred, and there are other people that are saying, well, actually, you got some of these laws that we use, like relativity there, that are off a little bit. And so, anyway, yeah.
Can you maybe kind of make comments on this issue that Einstein, that he couldn't accept the idea of the beginning of the universe expansion, so this so-called universal constant, he kind of fudged back to be consistent with this philosophical presupposition.
Yeah, so in his theory of general relativity, he saw that the implication was an expanding or a contracting universe, and that's not what astronomers believe. They believe everything was static, it was eternal, space had, it was eternal, it was static, and so forth. So he put in a little constant, call it a fudge factor, to make the answer to come out right? And that's called the cosmological constant. And then they discovered that the universe was expanding. He said, oops, I guess we didn't need that constant, and then he crossed it out. Well, it turns out they discovered that you do need a constant, but not to hold everything in place, to explain the fact that the universe is expanding at a faster and faster rate. So.
But wasn't my understanding is that the idea
was
very offensive because that suggests there will have to be a beginning.
Exactly.
So it was a philosophical reason for putting
it
scientific.
Yeah. So we'll get into that in a minute. So anyway, I like to say now we're in, I would call the astronomy, the space age. Of course, the last half of the last century, beginning of this one, is satellites. Now we're putting up telescopes, bigger and bigger telescopes. We're sending vehicles to other planets so that we can actually, photograph them, land on them, sometimes bring samples back and stuff like that. So all that enabled because of some guy by the name of Robert Goddard invented a liquid fuel rocket back in the 1910s. So anyway, so you probably heard of the James Webb Space Telescope. So here's the James Webb Telescope on the left, and then the Hubble right. You can see that it's a lot bigger mirror on the left. And the bigger mirror, the more light you collect, the more you can see and the higher resolution you get. But it also sees in a different spectrum. So Hubble sees the light that we see, the visible light. But there's other light that we can't see. You might say sounds too low that we can hear or too high that we can hear. So the universe, as you get further away, is singing at a lower and lower frequency. And so the telescope, the Webb telescope, is designed to watch the light or listen to the song, at that lower end of the spectrum, all the way back to as far as we can get to almost to the beginning of time, which is pretty fascinating. So I show an example here. So in the left is a Hubble Space Telescope image of a nebula in the visible light. But if you look at it in the infrared light can go through dust. And so now you can see stars that you couldn't see before. You can see through the dust. And so you can see the advantage of looking at these areas outside of the visible light range. All right, so let's move on. Hubble Space Telescope. So here's Earth on the left. Hubble Space Telescope is in orbit around the Earth. Though James Webb is in orbit around the Sun in a special spot called L2. And I won't explain what that was. I can explain it afterwards. But it's millions. Hubble is like 354 miles away. The moon, 250,000. Hubble is almost 1 million miles away. I want to introduce this book called The Privileged Planet. It was actually written back, I think, in 2003, 2004. And its point is written by a couple of believers, I think. One's an astronomer, and the other, I think, is more toward the philosophy side. But their thesis is that Earth, we're a privileged planet because God has placed us. We're in a place in the universe that's ideal for discovery. So whether you look at the constituents of our atmosphere, the type of star that we're in orbit around, our place in the galaxy, all this kind of stuff. And the whole thesis of the book is going through how this stuff is not only conducive for life, it's also conducive for discovery. It's almost as if somebody wanted us to discover these things. So God wants us to know. So I think it's interesting how technology continues to develop. We can see more and more. All right, so I mentioned the discovery of cosmic expansion, and so these two characters, Lemaitre, who developed the theory, and then Hubble, who confirmed it. As John said, it was not popular, right? They considered it as science destroying. This is just crazy. There's just no way this can be true. But they were forced to accept it as they got more and more data in that showed that the cosmic expansion was happening. And as far as it looks like the universe had a beginning. And the non-Christian, I would say, secular, and agnostic, even atheistic astronomers and physicists have a heck of a hard time with this. They continue to have it, but they're forced by the data to give it grudging acceptance. And one of the problems they have is with this fine tuning. So we talked about the laws of nature last week, and these equations have constants in them. We talked about the cosmological constant, the fudge factor. Well, they have other factors in there too, to make the answer come out right. Well, it turns out that those constants have to be tuned to 1 part in 10 to the 10th to 123 power in order to get the universe that we have. Anything like the universe we have. Yeah?
What's that last number after 10 and 10?
It's 10 to the 123rd power. So it's 10 to the 10th to the 123rd power. So 10 to the 10th to the 100th power is what we call a googolplex. So it's an unimaginably large number.
So what does that mean? That there's that many, one in that many number chance that we could be in this kind of universe?
Yeah, so divide that into 1 and it turns into a probability. So that 1 part in, so you put 1 and then over that number. So. All right, so talked about getting around the beginning. You're always reading stuff in the popular press about, the Big Bang, we discovered this, there's really not a Big Bang. And I need to get into it, and there's a bunch of hokey, right? Some of it's just, semantics, but the first one was steady state cosmology. Okay, the universe is expanding, but as the volume increases, then you have more empty space between galaxies, and other galaxies can kind of appear magically. Okay, so this is called the steady state cosmology, and they disproved that using radio astronomy, using radio telescopes. They showed there was a prediction made that if the Big Bang was true, then you would see this kind of radio, if you looked in a radio spectrum, you would see this across the night sky. And so they tested it, and sure enough, they saw it. And that disproved the steady state theory of cosmology. And then there's another one called an oscillating universe. Okay, so the universe is expanding, but eventually it's going to slow down, and then it's going to collapse again, and then it's going to expand. So you have this thing that's just, expanding back and forth like this, and it has been doing this forever. So that's another way of getting around the beginning. Well, number one, they showed that, there's a problem with entropy on this. It ends up being a big splat as opposed to a big contraction down to a point. And the other thing is, guess what? They discovered that the cosmic expansion is accelerating, not decelerating. Okay, so there's no way it's going to come back. There's been some recent incarnations of this, but I think those are, as people propose them, they're being discredited also. So then we have multiple universes. Turns out that needs fine-tuning too. Redefining nothing. Well, the universe popped out of nothing, but this is what we mean by nothing, So anyway, the last thing is denying the universe has a cause. Perhaps you could just say, why do we the universe has a beginning. Why does it have to have a cause? Why couldn't it just happen? Well, I like this quote from Chesterton. He said, if true, then nothing in the universe needs a cause. You can believe that the universe has no cause, but if you really believe that, you can't believe anything else. Your belief renders everything nonsensical. So if the universe itself didn't have a cause, then no cause is needed for anything inside of the universe either. So now we're going to take a tour of space. So, because the universe declares the glory of God. Of course, we know we're part of the solar system. So these are the inner planets right here. So here's Earth, third rock from the sun. We're kind of unusual in that we have a big moon. That's almost like another planet. In fact, the ancients called it another planet. And then outside of this, you have this asteroid belt. So these are a bunch of much smaller rocks that really haven't gotten around shape. And so that's the asteroid belt. And then outside of that are the gas giants. So here you have Jupiter. So these are made primarily of rock, and these are made primarily of gas. So you have Jupiter, Saturn, Uranus, and Neptune. And that way out here is Pluto, but it got demoted, and it's actually a rock, not a gas giant. Okay, so just to give you a sense of perspective. Okay, so here's a football field going across here. So they're scaling the solar system, so the sun is over here, and all the way at the 100-yard line is Neptune, right? So if you scale the solar system to that, how big would the sun and the planets? Well, here's the sun right here. Here it is. Here's the sun next to the, the sideline. Yeah, right. So, and now here you see the rocky planets right here. They're like the ball and a ballpoint pen. And then over here you have these BBs. Those are like the gas giants. So you can see how immense the solar system is. So that's all our lives are on the tip of that ballpoint pen. And so I think that's amazing. So of course we've sent spacecraft out. This is taken by the Cassini spacecraft, which was launched a number of years ago. Took beautiful pictures, did a lot of research on the planet Saturn. I love the way the rings look right here. I love the shadow there. It's so sharp because there's no atmosphere to scatter the light, right? So the very sharp shadow. So that's Saturn. But Saturn has rings. I think this is the outermost ring. So Cassini spacecraft took pictures of moons that go along the outer ring. They're called shepherding moons, and what they do is help the ring maintain its shape. And you can see these gravitational waves that are created as the moon passes by. So next, while we're out at Saturn, is its moon called Enceladus or Enceladus. I'm not sure which it is, but it's a water world. And as we've gone out, we've discovered a lot of these moons are actually icy moons. So you have a rock core, and then there's a water crust or water shell, and in some cases they think there is watery oceans underneath. And it turns out water is ubiquitous in the universe. It's ubiquitous in our solar system. And some of the moons around Jupiter, one of the moons, they've seen geysers coming out of it. They've actually flown through it to sample the plumes that are coming through the geyser and so forth. So here's our place in our interstellar neighborhood. So we looked at the solar system. This spacecraft right here has left the solar system. One of the fastest spacecraft to leave the solar system would take 95,000 years to reach the nearest star, which is like 4.3 light years away.
The fastest spacecraft we have now.
That's right.
Okay.
That's right. Fastest spacecraft we have now. So we need some technology improvements. If you have any ideas for warp drive or anything like that, could come pretty handy. All right, so here's the sun here, and here's the nearest star, Alpha Centauri, right there. So anyway, and all these stars in our local neighborhood. Now we'll move out a little bit. This is about 1,300 light years away. So that means life left this particular nebula about the time that the Middle Ages began. So here you can see the constellation Orion, this hourglass look right here. And then right here is the belt of Orion, and this is the sword of Orion. So this is, you can see all this in the night sky now when you look through a really good telescope, not this one. This is what you'll see. So
we're seeing something that was lit up 1,300 years.
That's right.
Right here.
Yeah. Yeah. All right, so these are called the pillars of creation because scientists think that what we're seeing here are actually planetary disks, stars and solar systems beginning to form. So this is interplanetary dust, and then you have like a star over here, the light from it and the stuff flowing out is kind of pushing this gas away, and you see these little nubbins here. It's almost like there's something, more solid or more dense right there, and the thought, I think, is maybe that's going to condense into a solar system around a star and so forth. So that is 6,500 to 7,000 light years away. Right? So we're in a galaxy, the Milky Way galaxy. So this is a 360-degree view panorama of the Milky Way galaxy. And so right here is the center of the galaxy. It's actually in the constellation Sagittarius, if you ever go out in the night sky and look up your constellations. This is the edge view because we're embedded in it. What does it look like from the top? Okay, here's what it looks like from the top. We're a bar galaxy. So the bar is here, and then these spiral arms come off the end of the bar. And so we are right here. We happen to be in between two arms, and that's kind of ideal for doing astronomy and actually for life to survive too. So if you look at these grid lines, so each line, each step, if you go out radial, is 5,000 light years. So if the universe is 6,000 years old, then you're a little bit over one grid line. So that means the starlight inside the circle could reach us in 6,000 years. But outside it would have had to start before then, all right? So from a young Earth creation standpoint, so the 6 literal days of creation, you have to account for the fact that these things are farther away from this. So how did that happen? So we're going to talk about that on lesson 9 when we get into interpreting Genesis 1, is how do young Earth creationists address the issue of interstellar distances. Anyway, so that's our galaxy. So here's our sister galaxy. Our sister galaxy is 2.5 million light years away. It's called the Andromeda Nebula. You've probably heard of the Andromeda strain. This is where it came from, right? But you can see these dark swirls. Those are actually dust lanes in the galaxy, and then all this light fuzz is really individual stars. And all these points of light you see here are within our galaxy, not within the Andromeda galaxy. Here's another galaxy. This would be a dwarf galaxy of some sort. And here's another one. So, okay, go out further. All right, so this is just a little bit further. This is 2.73 million light years away. This is Triangulum galaxy. And you notice all the color you have, and this is actually several images from several different instruments that have been combined. So you have different telescopes looking in different areas of the electromagnetic spectrum, then they combine them together so they can see like star forming regions and superimposed on the spiral arms and so forth. So that's kind of what that's doing. All right, so what I've shown you so far is part of our galactic cluster. So we have a group of galaxies that are kind of gravitationally connected to each other. It's called the local group. So here it is. Here's the Milky Way right here. See that little disk there? That's the Milky Way spiral. Over here is the Andromeda galaxy, and over here is the Triangulum. And this distance is 1 million light years from that point to that point. Okay. All right. Go out a little further. This is 60 million light years away. I think what a gorgeous picture. What a gorgeous picture. You know, and you know, you look at God's creation, and we are just less than a speck of a speck of a speck on the dust. It's incredible how little, how insignificant we are when we compare ourselves to these other things.
Just a matter of interpretation. When you say it's 16 million light years away,
Yeah.
are we saying that this is what it looked like 16 million years ago?
Yep.
Correct?
Yeah.
Which means that today it doesn't look like that. It's probably much more expansive. Is
Yeah.
that correct?
Yeah. We're always looking into the past, right? So, all right. Now I want to expand out further, and I have a little video to show you right here. So, I thought this video was really cool because it explores the local universe. By local, I mean the region around us out to about 370 million light years. This is local by cosmological standards. The original video was called The Cosmography of the Local Universe, produced by a group of astronomers in 2013 in the Astronomical Journal of the American Astronomical Society. The URL to the video is in the class notes. I have edited it here to shorten it up considerably and to add my own narration that is hopefully more understandable to lay people. The video takes the results of an astronomical catalog called the V8K Redshift Catalog. Redshift refers to the light stretching out due to the Doppler effect and the stretching of space due to cosmic expansion. As the light stretches out, it shifts toward the red end of the spectrum. This shift in an object's color correlates with its speed away from us. Thus V8K means the recession velocities of the objects in the catalog are all 8,000 kilometers per second or less, which for us Americans is 18 million miles per hour or less. Using Hubble's law, there is a correlation between the redshift and the distance from us. 8,000 kilometers per second corresponds to a distance of 372 million light years, which is less than 1% towards the edge of the visible universe. This picture views the entire sky as seen from Earth, mapped onto an oval so we can see it all on a screen. Something similar is done with maps of the Earth. Each dot is a separate galaxy, and its color represents the speed away from us. Blue dots are the slowest and thus are the closest galaxies to us, and the red dots are the fastest and thus the farthest from us. Let's plot these galaxies in three-dimensional space. Note the bluest are in the middle and the reddest near the periphery. Where are we in all this pile of points? In the center, of course. Let's find the Milky Way. The Milky Way is shown as a blue dot in the middle of the crosshairs. The Milky Way and its entourage and the Andromeda Galaxy and its entourage highlight the local group. Other galaxy clusters are also contained in this cube, roughly 40 million light-years on a side. There is some structure to these groups, including something called the local void and the local sheet. Zooming out further, we include a dense galaxy cluster called the Virgo cluster, which means it is in the direction of the Virgo constellation in our night sky. Now we zoom out to the width of the entire V8K catalog, 740 million light-years. But the depth of the slice is only 92 million light-years into the screen. Note the item called the Great Wall near the top of the screen. Next, let's look at a section cut about 46 million light-years thick. You may note bubble-like voids with galaxies concentrated in the filaments and nodes between them. Here's another one rotated 90 degrees from the first. Note again the filaments and nodes of galaxies. It is assumed that not all galaxies in the 744 million light-year cube are in the V8K catalog, since the farther away the galaxy is, the harder it is to see. An attempt to estimate the missing galaxies based on the presence of known galaxies is made and shown here as density contours. Note the structure we saw earlier called the Great Wall. Lastly, an attempt is made to infer the motion of galaxies relative to each other, once the cosmic expansion is factored out. First, the deviant velocities away from us are shown as arrows. Red is always from us and blue is toward us. Deviant refers to the departure from Hubble's law. Notice the bulk of the arrows point to the left, indicating a great something is pulling the galaxies and clusters of the galaxies in the local region towards it. Next, statistical techniques coupled with inferred mass distribution are used to develop streamlines for the flow. Finally, the streamlines are animated to show the flow of galaxies to the Great Attractor. According to Wikipedia, the Great Attractor is a gravitational anomaly in an intergalactic space. The observed anomaly suggests a localized concentration of mass millions of times more massive than our Milky Way. However, it is inconveniently obscured by the disk of our galaxy. So I hope when we talked about some immense distances. And what I want you to get from this is God is so much bigger than that. We have this immense universe. It's absolutely mind-bogglingly large. Things that just dwarf us in so many ways, whether it's the gravitational pull or the amount of energy that's being released and all this kind of stuff. And this all points to God's glory. God is so much more immense than that. Who made all these things? Right? So God is the one who cast it, who spoke it into existence. And so that's the point I want you to get from this. Here's some scriptures I wanted to share with you. So, God, the creator and sustainer of the heavens. So Nehemiah said, "You alone are Lord. You made the heavens, even the highest heavens and all their starry hosts. The earth and all that is in it, the seas and all that is in them. You gave life to everything, and the multitudes of heaven worship you." And then Job talks about God stretching out the heavens. He alone stretches out the heavens. And then Psalm 33, "By the word of the Lord the heavens were made, and the starry hosts by the breath of his mouth." The word is speaking, and just like that. So think of Jesus as the word of God. Think of the breath of God as the spirit of God. So the Trinity was involved in creation and in creating of the heavens. Just think of, think of that picture. And then Isaiah, it talks about God says, "My right hand stretched out the heavens. When I summon them, they all stand up together." They do whatever he wants. Attention. So, and then Isaiah 44, I just love this poetic language. He said, "This is what the Lord says, your Redeemer who formed you in the womb. I am the Lord, the maker of all things, who stretches out the heavens and who spreads out the earth by myself." So, as I mentioned in the video, we tend to think, we are nothing compared to the rest of God's creation. But that's really not true. We are loved by God. God pays attention to the tiniest details. All our hairs are numbered. All our days are numbered. He knows it all. And and in a sense, we are bigger than the universe, in the sense that we are eternal creatures. We have an eternal soul. Our existence is going to go on forever and ever, right? And the universe is going to get old. It's going to die out. It's going to be rolled up like a tent curtain. It says in Isaiah. So, and I love this, Isaiah 40, it says, "He who brings out the starry hosts one by one and calls forth each of them by name." Each star, he has a name for it and so forth. So, you think of a shepherd leading out his sheep, that poetic imagery of God leading out the starry hosts. Anyway. And you see also this idea that it's God's sustaining power also that they continue to exist, right? Because of his great power and mighty strength, not one of them is missing. All right. Next we go on to, God far superior to the heavens. So Psalm 133, it talks about his glory being above the heavens. And he stoops down to look on the heavens and the earth. Of course, this is all poetic imagery, but the earth is nothing to him. Famous mystic said that she had a vision of a hazelnut, a little tiny nut in the palm of her hand, and she told the Lord Jesus, "What is this?" And he said, "This is all that's been made." Compared to God. So anyway, talks about all the stars in the sky will be dissolved and the heavens rolled up like a scroll. God's going to do that. I love the imagery. All the starry hosts will fall like withered leaves from the vine, like shriveled figs from the fig tree. And then God revealing himself through the heavens. So your righteousness, God, reaches to the heavens. You can imagine that as high as the heavens are above the earth, so great is his steadfast love toward us. So great is his righteousness. So great are his thoughts compared to ours. Anyway. All right.
Amazing in the scripture how it describes God and the universe that we know about.
Yeah.
It was written thousands of years ago before any of these laws of Kepler or Newton or anything were made known, and that they had that knowledge.
Yeah. It's like they're saying, "Look, God, look at him." I think. So any questions, comments? Yes.
Maybe a comment. I know we as a Christian community have a love-hate relationship with the concept of Big Bang. We as a Christian community have this love-hate relationship with the concept of a Big Bang. My understanding of how that word came out was actually pejorative. That is to say that when Hubble and others have come to the conclusion that the universe had a beginning, that was so offensive because that suggested a creator. One distractor said, so, you mean there was a big bang or something? And that's how the term actually emerged.
Yeah.
So it's just, again, I think that the truth of God's word is always going to be there. The caveat is that science is a human method for understanding God's creation, and therefore it is limited, and it's always going to be provisional. So, but with that caveat, I think we could be very confident that the creation does declare the creator. And so, but scientists are human, and they are not Christians, and they're going to try and find ways to figure things out, including this multi-universe, because it's so highly unlikely we emerge, and therefore infinite number of multiple universes will explain that. Well, so all that to say, God could stand alone in all this.
Seems like the ancient cultures and the ancient year created gods that they could control. Meaning the gods had foils, and there's all, But our God in what their poetry meaning is so. He's look at those verses. He just cannot. He's past finding out. We can't. We're still trying to figure. He's revealed, but I can't think of it. I can't get there. So I can't put him in my level where it seems like now. I don't know if today would be. We just can't create. But there weren't atheists back. It seemed in ancient Near East. Ancient cultures. They had to just explain it somehow.
Yeah, well, yeah. So, so the ancient gods weren't like our God. Our God is the omnipotent creator who spoke everything into existence. The other gods, we don't know how they don't know how they came about, but often they explain the origin of the gods. It's like, what? Kind of thing. So they aren't gods in the sense that we think of God. They were lesser creatures, shall we say, I think, even in their imagination. But I think that language is always there, and for those who had open hearts, they could perceive that there was something behind it. There was a creator. So, of course, the big temptation for the ancient Jews was to worship the stars. Talks about them worshiping all the starry hosts, and that's why I think you see very little mention of the planets. It's more like they're used as illustrations. So, because of that temptation to worship the starry hosts and those planets that seem to control the affairs of men, things like that. Maybe we should quit, and because it's late.